Welcome to day 13 of the 30-day countdown towards the Further Maths GCSE. And yesterday's question, we're looking at stationary points of our function y, and we're stating if they are either maximum or minimums. So the first thing we're going to do to help us find these stationary points is find our dy by dx. This is going to tell us or help us find our stationary points. So we've got x cubed. We're going to multiply by the power and then subtract 1 away from the power. When we just have an x, we can just get rid of the x. And here, the minus 5 disappears. So our dy by dx is 3x squared minus 12. Now our stationary points is when this thing equals 0, because our dy by dx is going to tell us our gradient. So we need to solve 3x squared take away 12 equals 0. Now, despite this having an x squared in, we don't have to solve it like we would with a normal quadratic. We can just add 12 to both sides. 3x squared equals 12, and then we can divide by 3. So we're going to get x squared equals 4, and then we can square root. But we've got to remember, when we do square root, there's going to be a plus and a minus of the square root of this number. So plus and minus 2. So if I just remind myself of the equation, it was y equals x cubed, take 12x, take 5. Now, to find our coordinates, we're going to take each of our values for x, so our plus 2 and our minus 2, and we're going to put it back into our equation. So when x equals 2, y is going to equal 2 cubed, take away 12, lots of 2, take away 5. So we've got 2 cubed is 8, 8, take away 24, take away another 5, we're going to have minus 21. So our first coordinate is 2 minus 21. Our next coordinate is when x is minus 2. So y is going to be minus 2 all cubed, take away 12 lots of minus 2, take away 5. So this is still going to give us minus 8 for this bit, but this is going to give us a plus 24, take away 5. Minus 8 minus 5 is minus 13. 24 take away 13 is 11. So our next point here is going to be minus 2, 11. So we found our stationary points, but now we need to state whether they're maximum or minimum. So what we do here is we do d squared y by dx squared. So we're differentiating again. So we had dy by dx was 3x squared take away 12. It's from above. So if we differentiate that, we're going to multiply by the power. So 3 times 2 is 6. We reduce the power by 1, so it's just x. And this minus 12 is going to disappear. So now we've got our dy by dy squared, d squared y by dx squared. If we substitute in these two x values, so when x is 2, dy squared by dx squared is going to be 6 lots of 2, which is going to give me positive 12. Now, if this is greater than 0, this tells me that that point, 21, minus 21, is a minimum. So it's kind of like the opposite to what you think. If it's greater than 0, it's a minimum. When x is negative 2, d squared y by dx squared, it's going to be 6 lots of minus 2, which is going to be minus 12, which is less than 0. Therefore, minus 2, and it was 11 is a maximum. So today's question, write 2x squared plus 8x plus 5 in the form of x plus b squared plus c, where a, b, and c are integers.